section of chapter 7 is dilations and similarity. So the first thing we're going to talk about is a dilation. How many of you have ever had your eyes dilated at the eye doctor?
No.
Okay. So what happens to your pupil? It gets bigger, right? Or it gets smaller. Okay. But does it turn into a square or a hexagon? No, it stays a circle, right? Okay. So it's going to stay the same shape. It's just going to get bigger or smaller depending on what happens. So a dilation in geometry is very similar. It's a transformation. And that's a fancy word, bless you. Transformation that changes the size of a figure, but not its shape. Changes the size, so it's either going to get bigger or get larger, get bigger or smaller, but it's definitely going to stay the same shape. So if it's a circle, it stays a circle. If it's a rectangle, it stays a rectangle. If it's an octagon, it stays an octagon. All right, so we're going to have what's called the preimage and the image. Whoops, that's an A, sorry. Image. Preimage and the image, okay? They are going to be similar. Remember the symbol similar, just the wavy part of the congruent symbol. And then we're also going to have the scale factor. And that scale factor is going to describe how much the figure does one of two things, is either enlarged or reduced. Okay, so enlarged is obviously when it's going to get bigger. Okay, so we're going to say that it has a scale factor, or a K. That's just the variable that was picked to represent a scale factor, is going to be greater than 1. So it could be a fraction like 2/1, or 3/2, or 7. Those are all enlargements. So it's getting bigger. And then reduced is when your scale factor, your K, is going to be less than 1. So it could be a fraction like 1/2, 1/3, 2/5. These are all reductions. All right, so we're just going to do one example. We'll call this example number 1. We're going to find the scale factor. And we're going to have a missing point. So we're going to find the point U. Right, so we're going to draw a coordinate plane, but we're only going to draw the second quadrant. So over here, in this second quadrant, we're going to put some points. Try a different color here. Along this x-axis, we're going to have this point over here. We'll call it R. It's going to be at -12, 0. So not to scale. Okay. And then a little bit less, we'll call point T. It's going to be at -9, 0. At the origin right here, we'll call it O, because we're going to make a triangle out of it. And then coming up the y-axis, we're going to pick a point here. We'll call it U Right now, we don't know where it's at. So we'll just put our set of parentheses, and then in a minute, we'll figure out what it's going to be. Okay? And then up above it, we'll put point S, and S is at 0, 16. Okay? So what happens with these points is we can make triangles out of them. So if I connect T over here to U, I'm going to have triangle TUO, and it's going to be similar to triangle RSO. So if I connect R to S, it's going to make a triangle right here, right? So I have triangle TUO, and then I have triangle RSO. We're going to make TUO our pre-image. That's what we're going to start with. So RSO is going to be our image, what we end up with. Okay? So if we're going from TUO to RSO, is it going to be an enlargement or a reduction? Enlargement, right? You can see that just because it's getting bigger. That part of it's kind of easy, right? Okay, so we can actually take the two triangles and make a my brain is blanking, sorry. We can actually set up a proportion with it. The word just went right out of my head. Okay, so let's start with this triangle, the smaller triangle, the TUO. So from here to here, and I'm trying not to cover up my writing that I already did, we actually go 9 units. And from O to R, we go 12 units. Okay? So we're going to use that as the left side of our proportion. So I'm going to start with the smaller and go to the larger. So I'm going to do 9 to 12. Okay, because we could draw an imaginary line right here separating the triangle to this side and to this side. Okay, now we're going to do the right side, bless you, and we need the smaller triangle first. That's the one we want to find. So what should we call it? X units. So I'm going to put that X in the numerator. And then the distance from O to S, is 16 units. So if I fill in a 16 right here, then I've got this really nice proportion. How do you solve a proportion? Cross products. So let's go this way first. We're going to have our 12 times our X, set it equal to the 9 times our 16. So this is 12x equals, if you multiply that in your calculator, you get 144. And then when you divide both sides by 12, you get 12. That means this point U is where? 0, 12. So if we fill it in, we're going to have 0, 12. So point U, P-O-I-N, I can't spell today. Point U is at 0, 12, okay? So that's part of our question was find U, but we also need to find the scale factor. So our pre-image is TUO and our image is RFO. So we have to actually start with the measurements of our image, which is 12. Well, we're going to go on this side first, and then we'll do that side and make sure they're the same. To our 9. Can we reduce 12 over 9? Are they both divisible by the same number? They're both divisible by 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. And we have a reduced fraction. I prefer reduced fractions, but you could even change it into a decimal. This is a decimal, would be like 1.3 with a bar over it, okay? I prefer reduced fractions, but if all you're using is a calculator, you can get matching decimals, okay? Now let's do the right side of this, the two triangles. So the image was 16, so that becomes our numerator. And U was at, we found 12. So we have 16 over 12, and that can be reduced as well. Both of those are divisible by 4. So 16 divided by 4 is 4. 12 divided by 4 is 3. And oh look, same fraction. If you typed it in your calculator, you'd get that same decimal. Okay? So they want the scale factor, so you say K is equal to 4/3. That's your scale factor. All right? Finish copying that down, and then let's talk about your worksheet.